Hello, welcome to Trig class. I'm Mr. Recorder. Let's prepare for the Unit 1 test. Number 1, what is the length of side A? Well, we've got this angle here, which is 32 degrees. And then we want to find side A, which is this guy. We know that the hypotenuse is 40. So we've got an angle, the hypotenuse of a right triangle. This should have the little right triangle sign on it. And we want to find out this adjacent side. So what trig function relates an angle to the adjacent side and the hypotenuse? Well, here's good old SOHCAHTOA. Sine is opposite over hypotenuse. Well, that's not it. B would be opposite. Cosine is adjacent over hypotenuse. Hey, that's the adjacent side and the hypotenuse and the cosine of the angle. So we can use cosine. Cosine of 32 degrees equals the adjacent side over the hypotenuse, which is 40 in this case. To solve for A, we can just multiply both sides by 40. They'll cancel here, and we get A equals 40 times the cosine of 32 degrees. So now I can just grab my calculator, and I can type in 40 times the cosine of 32. And I get 33.36. Now I want to, you see this right here? That says radians. So my angle is not in radians, my angle is in degrees. So this answer is going to be wrong. So what I need to do is I need to click mode. And then I need to go down to where it says radians and switch that over to degrees. So I'm going to use these arrows, down, down. Switch it over to degrees and hit enter. So now degrees is selected. So I can do second and then quit. And now if you look up here it says degree. So if I re-enter 40 times cosine of 32, I get a slightly different answer, 33.92. So 33.92. A equals 33.92, which is probably this guy. Alright, find cosine of theta. Well, what is cosine? Cosine is the adjacent side over the hypotenuse. So the cosine of theta is the adjacent side over the hypotenuse. So we're going to use this picture. Cosine of theta equals, so here's theta. What side is adjacent to it? The 3 is adjacent to it. So it's going to be 3 over the hypotenuse. But what is the length of the hypotenuse? That is a riddle we can solve using the Pythagorean theorem. Got a right triangle, so the sum of the squares of the legs is going to equal the square of the hypotenuse. So 3 squared plus 5 squared equals hypotenuse squared. 3 squared is 9. 5 squared is 25. That's the hypotenuse squared. 9 plus 25 is 34. So then h is going to be, if we take the square root of both sides, we get square root of 34 equals h. So the hypotenuse is the square root of 34. So now back to the cosine. Cosine of theta is the adjacent side over the hypotenuse. So it's 3 over the square root of 34. But our answers don't have square root of 34 in them, so we can just punch this into the calculator. Three divided by the square root of 34 equals 0.5144. That is A. Ding. Alright, if sine of theta equals 1/3, then what is cosine of theta? Well, if sine of theta is 1/3, then that means we've got a triangle somewhere, a right triangle at that, where we have a theta, and then sine is opposite over hypotenuse. So the opposite side is 1, and the hypotenuse is 3. Now can we use that information to find out what the adjacent side is so that we can find cosine? Because cosine is the adjacent side over the hypotenuse. Alright, we can use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So let's call this A for now. A squared plus 1 squared equals 3 squared. So A squared plus 1 equals 9. If I subtract 1 from each side of the equal sign, I get A squared equals 8. Then if I take the square root of each side, I get A equals square root of 8. But 8 is 4 times 2. I'm simplifying this radical. 4 is a perfect square. The square root of 4 is 2. So A is, square root of 4 is 2, so the 2 comes out. So we brought the 4 out. Square root of 4 was 2, and then we have a 2 left inside. So A is 2 square root of 2. 2 radical 2. So now what was the question again? What is the cosine of theta? And we said cosine is adjacent over hypotenuse. So adjacent side is 2 radical 2 over hypotenuse 3. Ding, 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 ding. Okay, so you're standing 30 yards from a pine tree. The angle of elevation from where you are to the top of the tree is 12 degrees. Alright, so let's say you're standing here, and there's a tree over here. La-dee-dee-dee-dee. And you are 30 yards away from the tree. And the angle of elevation from you to the top of the tree is 12 degrees. So what we've got here is a right triangle, and we know this angle, we know the length of the adjacent side, and we want to find out the length of the So what trig function relates the opposite side and the adjacent side? That's going to be tangent. Tangent of an angle is opposite over adjacent. So in this case, the tangent of 12 degrees is going to be the opposite side, which is the height of the tree. So I'll just call that h for height, over the adjacent side, which is 30 yards. Alright, so if I was to multiply, it's asking how many feet tall is the tree. So 30 yards is, each yard is 3 feet. So if I multiply by 3, this 30 yards is 90 feet. So what we're really doing is tangent of 12 degrees equals h over 90 feet. Now if I multiply both sides by 90 feet, then I'm going to get the height is 90 times the tangent of 12 degrees. Since our angle is in degrees, we need to make sure that our calculator is in degrees mode. And then we're going to do 90 times the tangent of 12 degrees. And we get 19.13. So that is about 19 feet. What is the length of segment AB? So this guy right here. Well, we got some 30, 60, 90 triangles, and we can use our trig functions to figure out the lengths of these triangles. Just for convenience, I'm going to label this point D. And now I want to look at, first I'm going to find the length of segment AD, then I'm going to find the length of segment DB, and then I'm going to add them together to get the length of segment AB. Alright, to get segment AD, I have this angle, and I have the opposite side, and I want to find out the adjacent side. So opposite and adjacent, opposite over adjacent is the tangent function. So tangent of 30 degrees is equal to the opposite side, 18, over the adjacent side, which is AD. That's what we're going to try to solve for. What's the length of AD? So to get AD by itself, I need to first get it out of the denominator here. So I'm going to multiply both sides by AD. So I got the length of AD times the tangent of 30 degrees equals 18. Then to get AD by itself, I just divide both sides by the tangent of 30 degrees. So the length of segment AD is 18 divided by the tangent of 30 degrees. So I just grab my calculator, make sure I'm still in degrees, and I'm going to do 18 divided by the tangent of 30. And that's about 31.2. So AD is approximately equal to 31.2. Now I need to find the length of DB. And I'm going to use this angle. Opposite is 18, adjacent is DB. So I'm going to use tangent again. Tangent of 60 degrees is the opposite side, 18, over the adjacent side, which is DB. Then I'm going to follow the same thing I did up here. Multiply both sides by DB. DB times the tangent of 60 degrees equals 18. Divide both sides by tangent of 60 degrees. And you get DB equals 18 over tangent of 60 degrees. So now I'm going to do 18 divided by the tangent of 60. Make sure I'm still in degrees. 10.4. So dB is approximately equal to 10.4. And now I just need to add these together. 31.2, so this is 31.2, and this is 10.4. So all the way from A to B is going to be 31.2 plus 10.4, 41.6. Alright, number 6. A 6-foot tall man, so this guy is 6 feet tall, casts a shadow that is 11 feet long. So this is 11 feet. What is the sine of the angle made between the ground and the line between the top of the man's head and the top of his shadow? So we want to find this angle here. Well, we want to find the sine of that angle. Well, sine is opposite over hypotenuse. So opposite is 6, hypotenuse is, well, we don't know yet, but we can use the Pythagorean theorem to find out. Legs squared plus legs squared equals hypotenuse squared. So 6 squared plus 11 squared equals c squared. A squared plus b squared equals c squared. So 36 plus 121 equals c squared. 157 equals c squared. And now if we take the square root of each side, we get that c equals the square root of 157. Square root of 157. I'm not going to get a decimal for that yet, because if I round right now, I'm going to maybe round a little too much and then be not real close to one of my answers down here. So sine of theta, we're back to finding out what is the sine of this angle, right? Sine of theta is opposite over hypotenuse. So sine of theta is, the opposite side is 6, and the hypotenuse is square root of 157. So now I'm going to go ahead and put that in my calculator. Sine of theta equals 6 divided by the square root of 157. And that's 0.4788, which looks like it'll round to this guy right here. So now we need to convert 122.94 degrees to degrees, minutes, and seconds. Well, we have the whole number of 122, so that is 122 degrees, and then 0.94 of a degree. Well, there's 60 minutes in a degree. So this is 122 degrees plus 0.94 of a 60-minute degree. So our calculator is going to help us. We're going to do 0.94 times 60 minutes, and we get 56.4. So what we have now is we have 122 degrees, 56.4 minutes. So that really is 122 degrees, 56 minutes, and then 0.4 of a minute, and a minute is 60 seconds. So I'm going to use my calculator again to figure out how many seconds that is. 0.4 times 60 seconds is 24 seconds. So 122 degrees, 56 minutes, and 24 seconds. Now I'm going to convert 30 degrees, 15 minutes, 25 seconds to degrees. So what I got here is 30 plus 15 over 60, because there's 60 minutes in a degree. And then we got 25 seconds, and there are 3,600 seconds in a degree. So all I have to do is use my calculator to punch that up. 30 plus 15 over 60 for 15 minutes plus 25 over 3,600 for the seconds, and I get 30.2569, which would round to 30.26. When we're converting between degrees and radians, we're always going to be using the fact that pi radians equals 180 degrees. So we're either going to be multiplying by 180 degrees over pi radians, or pi radians over 180 degrees. And which one of these we use depends on which direction we're going, from degrees to radians or from radians to degrees. In this case, we're going from 85 degrees to radians. So 85 degrees times one of these two guys is going to give us some number of radians. Now, I want to cancel out degrees and end up with radians. So that means I'm going to need degrees on the bottom, so that the degrees will cancel. So I just need to grab my calculator and ask it to do 85 times pi divided by 180. And I get 1.4835, and that rounds to 1.48. Convert 3 pi over 8 radians to degrees. So I'm going to take my 3 pi over 8 radians, and I'm going to multiply by, now in this case I want the radians to cancel out and end up with degrees. So I want degrees on top, and then pi radians on the bottom. The pi's will cancel out. So I just need to get my calculator and do 3 over 8 times 180 degrees. And that is 67.5 degrees. Number 11, we're going to find the arc length of the minor arc indicated below. So AB would be the minor arc. Now there's two ways to go about this. We can use the formula S equals R theta, where S is the arc length, R is the radius, and theta is the central angle, but measured in radians. This one has to be in radians. Or we can find the circumference and multiply that by the portion of the circle. So in this case it would be 85 over 360. And I'll do both so that you can see that they both work. So S equals R theta. So the arc length would be 15, that's the radius, times theta, which is 85, But to get that into radians, we would have to, right now it's degrees, we would have to multiply by pi over 180. So, calculator, 15 times 85 times pi divided by 180 equals 22.25. Alright, now I'll show you the other way. The circumference is 2 pi r times the portion of the circle we're using, 85 out of 360 degrees. So that's 2 times pi times 15 times 85 over 360. Calculator, 2 pi times 15 times 85 divided by 360 equals 22.25. Sweet. Number 12. Find the arc length of the minor arc indicated below. This angle is already given to us in radians, so it's going to be easiest to use arc length equals r theta. And all we have to do is the radius, which is 7, times the angle, which is pi over 5. So, calculator, 7 pi divided by 5 is 4.39, and that rounds to 4.4. The arc length of the minor arc indicated below is 6.2 feet. So 6.2 feet there. Find theta to the nearest hundredth of a degree. Well, let's use s equals r theta. But we have to remember that this theta we get is going to be in radians. Then we're going to have to convert it to degrees. So the arc length is s, 6.2. The radius is 5. So to find theta, we're just going to divide both sides by 5. Six 0.2 divided by 5 is 1.24. So theta is 1.24 radians. But if I want to change that to degrees, I need to multiply by 180 degrees over pi radians. So times pi, no, times 180 degrees divided by pi radians. And we get 71.05 degrees. The arc length of the minor arc indicated below is 3.07 inches. Find the radius to the nearest hundredth of an inch. Well, this one we can use the circumference idea. We can say that 2 pi r times 62 over 360 equals the arc length, 3.07. So we would need to, let's see, these are all just numbers over here. 2 is a number, pi is a number, r is what we're looking for. 62 over 360 is a number. So I'm just going to figure out what those numbers are to make this look a little nicer. So I'm going to do 2 pi times 62 divided by 360, and you get 1.0821. So 1.0821r equals 3.07. I'm going to divide both sides by 1.0821, and that should give me the radius. So 3.07 divided by that is 2.84. B. If the point negative 2/3, comma, y is on the unit circle in quadrant 2, what is the value of y? Well, quadrant 2 is over here, and negative 2/3, comma, y would be somewhere like this. So y is going to be positive. And now this x value is negative 2/3. So we can draw a right triangle where this is our base, this is our other leg, and our hypotenuse is 1 because it's on the unit circle. The radius is 1. This leg is 2/3, and we can use the Pythagorean theorem to figure out the length of this leg. So we're going to call this y, and leg squared plus leg squared equals hypotenuse squared. So y squared plus negative 2/3 squared equals 1 squared. Y squared plus 4/9 equals 1. Subtract 4/9 from both sides, and I get y squared equals, let's see, 1 is 9/9 minus 4/9 equals 9 minus 4 is 5/9. So we get y squared equals 5/9. When I take the square root, you get y equals plus or minus square root of 5 over 3. So do we want the positive square root of 5 over 3 or the negative square root of 5 over 3? Well, since it's in quadrant 2, we want it to go up, so our y value has to be positive. So we're going to do positive square root of 5 over 3. What are the coordinates of the terminal point determined by theta equals 10 pi over 3? You know what's going to come in real handy on this problem? A unit circle. So 10 pi over 3. Let's see. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, and 10 pi over 3. So it looks like negative 1/2, comma, negative radical 3 over 2. What is cosine of 7 pi over 3? Here's another question where the unit circle is going to be kind of handy. All the way around the circle once is 2 pi radians. Well, so that's 6 pi over 3. So if we were to count by pi over 3's, we would go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, and then 7 pi over 3. We'd be right back at pi over 3. So what is the cosine of 7 pi over 3? The cosine is the x value of the terminal point. So the cosine is 1/2. Mr. McNichols is standing 47.3 feet away from a street light. His shadow extends 12.9 feet along the ground. All right, let's draw a picture of that. Here is a street light. Here is the ground. Here is Mr. McNichols. And then the shadow is going to come like that. His shadow is going to be down here. There's his shadow. Now he is 47.3 feet away from the street light, and his shadow is 12.9 feet long. The angle of elevation from the tip of his shadow to the top of the street light is 25 degrees. How tall is the street light? Okay, so what we're going to use is, we got this big triangle. We're going to find out the total length of this adjacent side, and then we're going to use tangent to find out the length of the opposite side. Tangent of 25 degrees is the opposite, which is the height we're looking for, over the adjacent, which is 47.3 plus 12.9. 2, carry the 1, 10, carry the 1, 60.2. So if I multiply both sides by 60.2, I get the height is equal to 60.2 times the tangent of 25. So, I need to make sure that I'm in degrees mode, so I'm going to mode myself back over to degrees. And I'm going to do 60.2 times the tangent of 25 degrees. 28.07. Hey, that's about 28.1. Well, that's the test prep. I hope you're ready. See you soon. Bye-bye. You are standing 30 yards from a pine tree. The angle of elevation from where you are to the top of the tree is 12 degrees. Approximately how many feet tall is the tree? All right, let's draw a picture. Here is your pine tree. There's the ground. There's you. Your hip is dislocated apparently. But the distance between you and the pine tree is 30 yards.